Okay, so this video is made to help you get 5 in a row on recognizing rational and irrational numbers. Now, in order for you to do this, you have to know what a rational and an irrational number is. Okay? So let's say we have a decimal, 3.242424, and I'm going to put a bar over the 2 and the 4. And that bar over the 2 and the 4 means the 2 and the 4 go on forever. 2, 4, 2, 4. So a decimal that repeats with a pattern. So this has a pattern. With a pattern is rational. Okay, so that's one type of rational number. All right, now all terminating decimals are rational. All terminating decimals are rational. So if I look at the decimal 3.216, because it stops, you can see right here that the decimal does not keep going. Because it stops, that's what terminating means. Then this is also rational, okay? So this one is also rational, okay? And so the only types of irrational numbers, irrational, are decimals that go on forever without a pattern. Let me say it again. So if a decimal goes on forever without a pattern, then it's irrational. And so an example would be if you type in your calculator the square root of 2. So everybody type in your calculator the square root of 2, and you get 1.41421, and it just goes on and on forever. And you can see there's really no pattern here. And so the square root of 2 would be considered irrational. Okay? Now, the square root of most numbers that aren't perfect squares are going to be irrational. Another example of an irrational number would be pi. Okay, so if you put pi in your calculator and pressed enter, it gives you 3.1415926, and it goes on and on and on and on and on, and there's no pattern. Since the decimal doesn't stop and there's no pattern, then it's irrational. So pi is irrational. Okay? So let's look at this. All right? So this question says, indicate whether each number is rational or irrational. So let's type 95 over 4 in our calculator. And when we do, we get 23.75. Now that's a decimal that stops. Since it stops, it's rational. Okay? Let's look at this second example. This decimal, this bar above the 0.357 indicates it goes on forever, but notice it goes 357, 357. It has a pattern. And since it has a pattern, it is also rational. Okay? Let's look at our third one. Square root of 7 over 3. Type that in your calculator. The square root of 7, close the parentheses, divided by 3. Okay, so in your calculator, when you type this in, it should look like this. The square root of 7 over 3. In other words, in your calculator, you got a square root and then an open parentheses, 7. You should close the parentheses and then put divided by 3, like that. And that gives you 0.881917. There's no pattern. Since this is a decimal that goes on and on forever, and there is no pattern, then it's irrational. Okay, let's look at pi minus 1. Okay, so if I type in my calculator the pi symbol minus 1, so I'm typing this right here, just like you see it. The pi is right below the clear button. So when I type that in, it gives me 2.141592. There's no pattern. Since it goes on forever without a pattern, it's irrational. And then let's type in our calculator negative square root of 5. Negative square root of 5. And I get negative 2.23606. There's no pattern. Since it goes on and on forever without a pattern, it's also irrational. So now let's look at these 5 examples. 1, 2, 3, 4, 5, 6 examples. Okay, 45.0 is a decimal that stops, so it's rational. 6 1/4 is the same thing as 6.25. It's a decimal that stops, so it's rational. 0.125 is a decimal that stops, so it's rational. 5.5 with a line over it means 5.5555, and then that 555 goes on forever, but it has a pattern, so it's rational. Let's put square root of 5 in our calculator. Square root of 5 is 2.236, and it goes on and on without a pattern. Since it goes on and on without a pattern, it's irrational. And then we already talked about pi is irrational. All right, let's look at these 5. Now, in Khan Academy, I had already filled it in, but that doesn't mean that this is rational or irrational. Let's study it. Type in your calculator the square root of 7, and it gives you 2.645751, and it just goes on and on and on forever. Okay, and that makes it irrational because it doesn't have a pattern. All right, now we know pi is irrational. Well, if you multiply it by 4, it's still going to be irrational. 3.2 is a terminating decimal, so it's rational. 0.45 is a terminating decimal, so it's rational. 0.245 with a line over it means 0.245555, and it just keeps going forever, but it has a pattern. That makes it rational. All right, let's do one interesting one. Let's say we had 501 divided by 502. Now, the true definition of a rational number is a number that can be expressed as a fraction. Okay? So if you type this in the calculator, it's going to give you a decimal that goes on and on forever without a pattern. Okay? But since the top is rational and the bottom is rational, then the decimal has to be rational. That means at some point, the decimal is going to stop. And so if I have 4 over 7, that's rational because I have a rational number on top and a rational number on bottom. So if you have a fraction where there's a rational number on top and a rational number on bottom, then the result is automatically rational. But now let's say that you have the square root of 2 divided by 5. Okay, 5 is rational, but the square root of 2 is irrational. So your result is going to be irrational. So now go on Khan Academy and see if you can get 5 in a row on recognizing rational and irrational numbers.